All right, lesson 7.4 is logarithmic functions. The first thing that we're going to do is we're actually just going to discuss in this first video actually what a logarithm function is. We're going to learn how to evaluate logarithmic functions. And then to complete lesson 7.4 out, you'll actually need to watch also watch lesson video 2 because there's some important information that you'll need also in there. And make sure that you print actually both note sheets. So before we actually discuss these, there's a couple of things that I wanted to show you that logarithms are actually used for. So the first one would be, for example, in chemistry, how to calculate acidity. In other words, a pH level. Most commonplace I've seen pH levels is in pools. Telecommunications with electronics and acoustics. The Richter scale, measuring earthquakes. Spectrometry and optics. The absorbance unit used to measure optical density. Astronomy measures the brightness of stars. Psychophysics, which measures the relationship between stimulus and sensation. Other uses would be information theory, used to measure the quality of information. In geometry, you can measure it for half-plane hyperbolic geometry. Engineering, scientific data, inferential statistics, even in musical intervals that are measured logarithmic and semitones. Okay, and in general, it just makes some computations easier because a lot of the problems that we're going to have now, where we've been solving, like if x to the third, x squared, we've been solving equations where the variable or the exponent is actually a number. Even some of them that we've had where we've had a fraction in the exponent. Now we're actually going to be solving what logarithmic functions or logarithms help us solve is ones that where the variable actually ends up in the variable. Okay, this next slide is probably the most important information. I call it circle bin because this is the way that the log is actually going to look. The b is known as the base of the log. Okay, so that little b right there is known as the base. And when you what basically what a logarithm is if I told you to write it in log form, this is what it'd be. It'd be log base b to the n, log base b n equals e. And if I wanted you to write it in exponential form, is you would actually need to start with your base. You would circle, pick up the e, and then circle around and pick up the n. That's where we get the circle B-E-N. So, and basically it ends up this. B is the base, e ends up the exponent, and n is your number. So b still remains the base of the exponent, as well as the log. E is your exponent, and then n is your number. Okay? All right, so let's take a look at a couple of examples. And we're going to basically, they're in logarithm form now. We're going to basically write them in exponential form. So when you do this, you always start with the base of the log. So in this case, it would be base b. And we're going to circle around, pick up 5. So it ends up 2 to the 5th equals, circle back around and pick up the 32. Okay? So it'd be 2 to the 5th equals 32. And when you're done, it should actually be a true statement. Okay? So then the second one, 5 to the 0 equals, and then equals 1. Okay? Start here at the base, 10 to the first equals 10. Okay? And that's pretty much solving it. Okay? It can also work for fractions. So in other words, remember that if my base ends up larger, if my base ends up larger than what this is, so 10 to the negative 1 equals 0.1. Okay? So remember that anytime you have a negative exponent, all it does is move the problem up and down. Okay? So this is the same as 1/10, so it would be the same as 1 over 10. This, start with 1/2, and remember, I circle around and pick up the negative 1, and then I circle back around and pick up the 2. So remember, negative exponents just simply move it up and down. Okay. The last part that we're going to do is actually solving logarithms. So since this isn't an equals, we're going to put equals, and I don't really care what variable you put. So basically, you're going to look to 3 to what power will equal 81. Okay. Now, easiest way to do this, we will be solving these, but you need to find out, okay, 3 times how many times? Well, what happens if I take 3 times 3? Well, that gives me 9, so that's not it. Well, 3 times 3 gives me 27. Okay. 3 times 3 times 3 times 3. So if I do it 4 times, the answer is 81. So since it's an exponent, I multiplied 3 4 times. So the answer in this case would be x equals 4, because I have 4 3's. Okay. All right. Number 5, or the next one. Remember my log base. I'm looking for my exponent. So 5 to what power will give me 0.004. Well, one thing that I would actually do on these, whenever it equals a decimal, is turn it to a fraction. Because believe it or not, fractions are going to be easier to work with in this case. So 4 over, and remember there's 3 zeros, so it's 4 1,000th. Okay? If you simplify it, 4 will go into both of them, and you find out you get 1 over 125. Well, remember, anytime the number ends up in the bottom, you automatically know that your answer is going to be a negative. Okay? So it's going to be a negative. Then you just got to find what times itself, or 5 times itself, how many times will give you 125. Well, it's not 5. That's 5 to the first would give you 5. 5 times 5 would give you 25. So it's not 2 times. And it's not 5 times 5 times 5, okay, which would give you 125. So we multiplied it 3 times, so the answer would be a negative 3. Okay? All right. And so the next one, we have a half to what power will give us 8. Well, it also works the other way. I automatically know that if I move this 2 up, my variable is going to turn into a negative. So then I've just got to find out 2 times what? How many, or 2 times itself, how many times will give me 8? Well, I know it's not 1. 2 times 2 is 4, so that's not it. 2 times 2 times 2 gives me 8. So I find out 1, 2, 3. So x has got to be a negative 3. And it's a negative 3 because I had to move the 2 out of the bottom. Okay. All right, the next one. Okay. Now this one, these get a little tricky because we're actually asking 9 to what power will give me 3. Okay. And I find out that, well, there isn't really anything because 9 to the first power is 9. 9 squared is going to be 81. So it's really none of those. So you got to actually think, okay, well, then you got to start looking at fractions. And when you're going from a big number to a small number, you say, well, wait a minute, the square root of 9 is 31. So anytime you take the square root, it's going to be a half. Remember, the square root of a number is actually 81 to the half power. Okay, those are actually means the same. Okay, so x would be 1/2 power. Okay, all right. Well, this concludes video 1. So I would suggest go ahead and watching video 2. Go ahead watching video 2, and then complete your quick check.